Hi, welcome again. Today I am explaining chapter 7 about equilibrium. Then there is one part called ionic equilibrium calculation. The last lesson we learned how to calculate pH of a solution when you have only one substance in that solution. We have three formulas to do that. Formula number 1 is to calculate concentration of H plus, number 2 is to calculate concentration of OH minus, and number 3 is to convert Ka and Kb. So if they give you Ka of a certain weak acid, you can calculate Kb of its conjugate base, and the other way around also. Now I change the question in such a way that the question is not asking for pH. Instead they give pH and they ask something else, either the concentration of the substance in the solution, or they ask for the dissociation constant. And to do that is very simple. We can just calculate, make the dissociation constant as a subject. This is how we modify formula number 1. Ka is concentration of H plus square over acid, and concentration of acid is equals to concentration of H plus square divided by Ka. So these two formula is derived from formula number 1. Similarly, we can do the same thing for formula number 2. We can make Kb as the subject or concentration of base as the subject. The question is given here. pH is also given. The first thing to do here is when you're given this type of question, what must we do is we must decide what type of substance is given in the question. I think this is quite easy for you to do that. Concentration of ethanoic acid is of course a weak acid. Sodium ethanoate or CH3CONA is either you call it a weak base or you call it a conjugate base of ethanoic acid. Aqueous ammonia is of course a weak base, and concentration and ammonium chloride or NH4Cl is of course a weak acid, or you call it conjugate acid of aqueous ammonia. HNO3 and NaOH is of course strong acid and strong base. Now how are we going to calculate this? Very simple. pH is given, then we were asked to calculate backwards. For question, the first row, question number 1, pH is given 3.55 and it's a weak acid, so we are going to use formula number 1 and make Ka as a subject. So pH is 3.55, so H plus is 10 power negative 3.55, which is 2.82 times 10 power negative 6 mole per dm cube, of course. So Ka, if we use formula number 1, that number we must square it, then divide by the concentration of the weak acid, which is 0.04 given in the question. So we get 1.99 times 10 power negative 6 mole per dm cube. Question number 2, pH is also given. Question number 2 is involve a weak base. So we use formula number 2. So pH we must convert to pOH. Very simple. 14 minus 9.2 is 4.80. Concentration of OH minus is 10 power negative 4.80, 1.58 times 10 power negative 5 mole per dm cube. We need Kb. To calculate Kb, simply use formula number 3, make Kb as a subject. So Kb is Kw over Ka, so 1 times 10 power negative 14 divided by Ka. Don't forget to put bracket. 2 times 10 power negative 6, you get 5 times 10 power minus 9 mole per dm cube. Now we can use formula number 2 and make concentration of base as a subject. So this one 1.58 times 10 power negative 5, and you must square the number and you must divide by Kb, which is, don't forget to put bracket, 5 times 10 power negative 9, 0.0499 mole per dm cube. Simple. We just need to reverse make concentration of base as a subject. Similarly, question number 3 is calculating weak base. pH is given. Since we are calculating a weak base, we must calculate the pOH. So 14 minus 10.52, you get 3.48. Concentration of OH minus is of course 10 power negative 3.48. You get 3.31 times 10 power negative 4 mole per dm cube. To calculate Kb is a weak base, so we need to use formula number 2, but make Kb as a subject. So we must square the concentration of OH minus, and you divide it by 0.06. You get 1.83 times 10 power negative 6 mole per dm cube. So that's how we can calculate either the concentration or the saturation constant of a certain solution with only one substance in the solution. So we just modify the formula.